Okay, again, happy Friday. It is week 5 Friday, so today marks kind of the halfway point of the quarter. And I don't know how you guys feel about this quarter, whether it's been dragging on or if it seems like, oh, I can't believe it's already been halfway. I don't know. It's a little bit of both, right? It's like, it feels like January felt like a long month. But then again, it's also like, oh, I don't remember being back in school this long. So anyway, we got the midterm coming up next week. That's going to be on Wednesday. And so I posted, I don't normally post old midterm exams. So usually I just kind of give a description of what the midterm exam looks like. Or what the exams look like. So, for the final exam, I'm not going to be posting a practice thing or anything like that. But, for this, for the midterm, I posted up this file, and it lists off what lectures you can expect, content from to appear, and then it also has kind of the questions. So, and it's basically just what is R going to output. Okay, what is R going to output when you run this code? So, can you read this code and in your mind know what R is going to output? And basically, to get your answer, you can just type the thing into R and see what it outputs, and that's going to be your answer, right? I wrote, don't share this file, or because sometimes I'll find my stuff online, and it always kind of upsets me a little bit. So please don't do that. But you are allowed to ask questions about the problems on CampusWire. The CampusWire you can ask, and you can say, hey, you know what, question 3, why are we getting this for this thing? I can see that this is what R is outputting, but I'm not quite sure if I understand why. That's totally fine. Okay, you can totally ask that on CampusWire. The one thing I don't like is just, do we need to know this topic XYZ for the midterm exam? Do we know how to do this or something? Do we need to know how to do this? I'm not going to be answering those questions, and your peers certainly don't know the answer either. So it's kind of pointless to ask. But other than that, hopefully the practice midterm or this thing will explain what you can expect to see. Of note, lecture 3-2, which was basically the RVest web scraping lecture, and we did things like importing and exporting data with read CSV and stuff like that. That will not. I won't ask questions related to that on the midterm. But the other lectures, basically from week 1 up through Wednesday's lecture, which covered R6, you can expect, probably a little dabbling of content from each of these things. Now, as with any exam, there's always a risk you study too much on one section and not enough of another, and I don't know how to tell you how best to split up your time. But that's always, that's just how studying goes, right? I will include the cheat sheet for regular expressions, and I don't know. You guys want a cheat sheet? Sure. Okay. All right. I'll specify. You can bring in a sheet of notes. Okay. It's not intended to be like the open note, open book, but sure, if you want one sheet of notes, we'll do that. I'll clarify, just so people are like, I thought I heard him say this in class and I don't remember. So I'll make sure I'll post a notification on, or at least a little note on Canvas here. Okay. Well, that's that. So you can take a look and start studying. I don't think this applies to you in the classroom, but I will. So if you haven't already responded to the survey, on whether you are available in the morning or evening, or you have a preference or something. Make sure you do that today. I'm going to send out assignments, time assignments, probably sometime this weekend, okay? Where I'll say, you're assigned to the morning, show up to this classroom, this classroom in the morning, or show up to the other classroom in the evening. And I'll send out time assignments, this weekend. And then next week, I'll send out seat assignments. I know that's a weird thing, but when I first started teaching, I'd let students sit wherever, and then I had a couple of incidents. I had this thing where basically like two friends were sitting next to each other, and their answers were unusually similar, and I had to refer them to the dean of students. And then it happened like the next quarter, something similar happened in the next quarter with other students. I was like, all right, I'm going to just assign seats. I know it's like old-fashioned, but after assigning seats, that issue went away. So you'll get next week, probably like Tuesday, you'll get like a little map of the classroom with seat numbers, and it'll be like, you're sitting in this seat number. Now, your seats don't have numbers on them, do they, or do they? Okay. All right. So I will just make up some numbering systems, because some classrooms, like, the seats are actually numbered, but I don't think this is one of those classrooms. Okay. So that's fine. I will just make up numbers. This will be like row A, and that'll be row B, and so on and so forth, and seat 1, and etc. So I'll make up numbers, and I'll send them out, and you'll get your seat assignments. Any questions? Okay. All right. Well, let's go ahead and take a look at today's lecture, which is covers ggplot. Okay. Now, there's a little. Whenever I do this lecture, some students are already very, very familiar with ggplot, and some students are like, yeah, I saw ggplot, but I'm not super comfortable with it, and this lecture turns out to be helpful. So if you're one of the students who are already very familiar with ggplot, my apologies, and I hope this lecture is not too boring, and hopefully you still learned something, but this one's mostly for the students who only just know a little smattering of ggplot, and this hopefully gives you a little bit more insight. Okay, and ggplot is super robust and deep, and there's like a lot you can do with it. Okay, but we'll just kind of cover the very basics, and at least cover this concept of a grammar, which is what the GG and ggplot stands for, is grammar of graphics, and at least we'll cover the grammar of graphics, and hopefully that will at least give you the framework in your mind to work with the other stuff that ggplot offers. Okay, a lot of this is coming from this textbook, Our Graphics Cookbook, and you can read it for free online. I love this new trend where a lot of authors are making their content freely available online. Of course, if you want a paper version, you got to pay for that. But if you're okay reading in your browser, and I think a lot of you are, it's pretty great. The only thing, so I tried to make sure we get free textbooks for almost all my classes. Next quarter, 102B, I'm teaching one lecture of 102B. That one I have a textbook that you have to pay for. I couldn't find a textbook that I liked that was free. So that class, you have to purchase a textbook. But the other ones, I try to stick to quality resources that are freely available. But yeah, when do you guys register for classes? Pretty soon? Next week. Okay, all right. I got one lecture, 102B. It fills up quickly, so hopefully you guys can get in. But yeah, just one lecture. So, what's that?
How many people do you have in your
So I have 2 lectures of 102A, and they both have 80, so are like 78 or something like that. I don't know, you know. So yeah, they started off with 80. A couple students dropped out, and then you know, about half of that come to class. I don't know. So, but I still have fun, and I'm so happy you guys are here. Okay, and you know, and those of you who are online and watching the video, I'm happy you're in my class too. Okay. And no, really, I know a lot. There's a lot of reasons why people don't come to class, and I'm not blaming anybody for not being physically present in class. So I am happy that you guys are here, especially, you know, if you're participating on campus wire. You know, I see the participation there. So you know, everyone's able to contribute. So I appreciate that. Okay. All right. So we're talking about ggplot. Grammar of graphics is kind of this. So somebody thought philosophically, like, what is a data visualization? Leland Wilkinson, and he came up with this concept of this grammar of graphics and says, this is what is happening. When you are looking at a chart, your brain is processing things. The person who made the chart did this. And it's like, oh yeah, that actually, you know, I never thought about it that way, but it works that way, okay? I'm a big fan of ggplot, okay? I promote it and all sorts of stuff. But I'm also not like blindly saying ggplot has to do everything, okay? I'm also a big fan of base graphics. You can do quite a bit in base graphics, and especially if you just want to do something quick and fast, you can often do it in base graphics. No problem there, okay? Big fan of the tidyverse, but I also love base R as well. So don't confuse me for someone who doesn't like base R. And I'm assuming you've already seen a lot of base R stuff in Stats 20 or your other classes, okay? And so let's talk about this grammar of graphics. And the idea here is we are mapping, when we create a data visualization, we are taking information in the data and we are mapping them from kind of like the data space, which would be like the real number line or something, and we're mapping those into the properties of visual space. Okay, what are you talking about? So like the number line can go into, like me just doing this thing where I'm doing the number line, right? That is taking just this arbitrary concept of values and then putting it onto some concept of distance. Okay, I'm mapping from this conceptually, like if you think what is a number, and it's like this abstract representation of quantity or something, and then I'm now somehow, like, just by doing this, you can visualize like it as distance, right? And we've been doing this probably since you were in like first grade, the concept of a number line. So we're very accustomed to that. Okay, but we can also so that makes sense. Visual properties like the X position or Y position, that's fine. But you can also map data properties to things like the size of the points or the color of the points or the symbols used for their points, okay? And you know, if your data is tidy, the properties of the data are basically each of the variables in the columns. So you might have, if you've got a data set on people or something, you might have the person's height, their weight, their gender, their race or ethnicity, their hair color, et cetera, et cetera, et cetera. And in this visualization, we're mapping from properties of the data to visual properties. So here is just this fictional data set, completely made up. We're going to say we have a person, 62 inches tall, 120 pounds, female gender, hair color brown. I guess gender would be feminine. And okay, and then so here it is, right? Okay, 67 inches, 140, feminine, black hair. Okay, and then we're going to say, all right, how do we make a diagram of this data? Okay, so what I'm going to do is I'm going to take height, I'm going to take weight, and I'm going to say take the height and map it. Okay, and so we create this mapping between the visual data properties to the visual properties. We're going to say take the height put it along the x-axis. Take the weight, put it along the y-axis. Take the gender, which currently in our data set we have F and M, put it in the color space. We're going to represent gender using color. Take the hair color, which we currently have brown, black, and blonde hair represented in our data, and map that to the shape. Okay, and we're going to plot this. And this is, okay, there were grid lines, but you can't see them on the screen here. Maybe in the video you can see it. But there were grid lines. But anyway, we have now mapped all the information that was in this table is now in this graphic. Okay? And here's the important thing, is that we can also take this graphic. If I were to give you this graphic and I say recreate this table of data, you can do it. Okay? You look at this point in the corner and you say, all right, this person has a weight of 120. This person has a height of, I'm guessing, 62. This person's gender, because the color here is whatever color this is, red-ish, okay, will be feminine, female. And this person's hair color, because it's showing up with a square, is going to have brown hair. So you can fill out that entire row. And you can go through every single one of these points, and you can recreate the entire data table, okay? So all of the information that shows up here is also represented here, okay? And so the reason why visualizations are so effective is because our brains and our eyes are able to see and recognize patterns just inherently. We have this ability to look at the sky and find patterns in the stars. We can look at clouds and we see things that we recognize. And you drive along the highway, on a farm, and you automatically just recognize all of these kind of patterns of rows and shapes and things like that, okay? So we're able, versus looking at the numbers, we can process this information, yes, which is a miracle if you think about it, okay? If you just pause for a second, right? Your eyes have to recognize this squiggle of a line, and you go, oh, that represents the value 62, which your brain has to think about this, right? And we process, truly, it's amazing. We see these kind of squiggles of lines. Our eyes recognize them as characters, and then give it meaning, and we have this thing. But it has to go through several steps to kind of arrive at this concept of a person of height 62, weight 120, female gender, and brown hair, or something like that, okay? And, whoops, something happened over here. Okay, whereas over here, just visually, we can now kind of just see a pattern already with our data. We say, okay, in general, at least with these data sets, in general, people with lower height have lower weight. People with higher height tend to have higher weight. And that's something we can see visually, whereas we might be able to pick that out, but it would take time of staring at these numbers to kind of pick out that pattern, right? And so the visualization is powerful in that it bypasses this requirement of having to look at numbers and think about what these things are, and we can just kind of recognize patterns with the dots already. Okay, when we look only at numeric values, our brain is not able to quickly reason about them. Okay, when we see when we see the values represented as points, our brain is able to visually process the information and identify patterns and relationships much more quickly. And the whole point of this data visualization is there's two parts. One is to map the properties of the data to the graphic, and equally important is for the person to be able to receive it, okay? Is the person has to be able to look at the graphic and recreate the data in their brain, hopefully in a kind of a quick way. It's kind of like this like this translate process, right? You've got the data, and you can kind of enter it into your brain directly by staring at this, okay? Or the other is you can create a visualization. You go from the data to the visualization, and then when you look at the visualization, you're able to receive the data, okay? So again, looking at the scatter plot, we can go point by point and recreate the entire data set if we needed to, okay? All right, so a little bit of terminology, a little bit of theory. Oh, I'm talking way too much. Let me give you your first view quiz answer. Today's first view quiz answer is the letter B. B as in bear. B as in bear, okay? So just some terminology. The data is what we want to visualize. It consists of variables, which are stored as columns. Geomes are geometric objects drawn to represent the data, such as bars, lines, and points. Just in case you didn't hear, the first view quiz answer is B. B as in bear. B as in bear is your first view quiz answer. We have aesthetic attributes, which are the properties of the geometric objects, the geomes, such as the position in X and Y, or the color of the line, the shape of the point, etc., etc. You have a mapping from data values to the aesthetics. Scales control how we map values from the data space to the aesthetic space. And guides are there to help the viewer map from the visual space back to the data space. So a guide would be something like labels along your x-axis or a legend, and that allows the viewer to look at it and go back to the data space. If I had given you this thing and I had removed this legend, or I had removed the labels along the x-axis, you would not be able to recreate the data values. Okay, so those are necessary as far as going from the visual back to the data space. So if we just revisit our creation of the ggplot, right? What are the commands that go in here? We say, okay, the data is coming from a certain data frame. It's the first argument, which means we can call ggplot and put in data equals data frame, okay? Or you can also chain it through a bunch of pipes. So you could do, a bunch of like dplyr frame manipulation and then pipe it into ggplot, and then that data frame that you've produced will go in as the first argument in ggplot, okay? The next thing that you need to provide is a mapping, okay? And the mapping is done within, you use the AES, the aesthetic attribute function, okay? And you're gonna specify the attributes of the aesthetics and map them to variables in the data. So over here I'm saying the variable height goes to X, variable weight goes to Y, and so on and so forth. And then you also specify how we're going to represent these things. And here I'm going to say I'm going to use points, point objects, point geometries to represent these things. But there's other geometries like the line and the bar and things like that. ggplot will automatically kind of create scales and guides on its own, unless you specifically say, I want this particular scale values, I want these particular guides or things like that, okay? So, so automatically it chooses kind of the lower left corner based on values. It automatically chooses the colors and the shapes. And then the guides also, the legends and the axis lines and the tick marks and the labels are also kind of created automatically by ggplot, but we can customize them as well. So this is what we've done. This is what we've created. We've mapped height to the X position, weight to the Y position. We've mapped hair color to the shape of the point and gender to the color of the point, okay? That's what we did when we specified this. We could change this, and so I'm going to leave everything the same, but this time I'm going to map hair color to the color of the point and gender to the shape of the point. So when we do that, we have three hair colors, blonde, brown, and black hair. So we're going to see three different colors of points. The gender, at least in our data set, we have two genders in our data set, okay? And therefore, when we look at the data, the visualization, there will be two shapes in our visualization, okay? And again, if you had another data set, maybe you have someone who's non-binary, you would have a third shape in your data set, okay? But in our data set where we only have 6 people, this is what we have. We have 3 colors of hair represented, and they get different colors. So this data visualization shows the same data as this visualization, but they look a little bit differently because here, hair color is mapped to the shape. So we have 3 different shapes. Gender is matched to the color. We have 2 different colors. Over here, we have 3 different colors and 2 different shapes. Okay. Now, our eyes generally pick out colors more quickly than the shape of the points. Okay. We can identify both of them, but our eyes are drawn a little bit more quickly to the color than it is to the shape of the points. So, the first thing you're going to probably notice is that you've got 3 colors here. And then after a while of staring at it, you'll go, oh, I also see triangles and I also see circles. Okay? So, generally it's recommended to put the important categorical variable to color and the less important one to be something like the shape. Okay? What happened if I mapped hair to the y-axis? What would happen if I mapped weight to the color? What would happen there? Is that even possible? It is possible, and this is what it would end up looking like, okay? So again, the same data, this looks totally different now. Hair color, we put to the y-axis, and so we're accustomed to having this visual thing where, you've seen X and Y coordinate planes throughout your, I don't know, since what, 5th grade or something? Whenever, okay? And so we're used to seeing numbers represented vertically and horizontally, okay? But just as well, we could just, arbitrarily take the names that we see in our data set, black hair, brown hair, blonde hair, whatever, and just put them at just arbitrary positions vertically, okay? And we're going to say anything that shows up right here, okay? This represents black hair, this represents blonde hair, and that represents brown hair. Weight is numeric, and we put it on the, we mapped it to the color attribute, okay? The color aesthetic. And so what does this mean? Well, how do you represent numbers with colors? Well, we've created a gradient, okay? ggplot sees this as a number and says, okay, we're going to have a gradient. We're going to have dark, dark, dark blue, almost like a black color, representing the lowest value, and then the brightest color of blue here representing the highest value. And so this is a lot harder to go from the visual space back to the numbers, right? If I said recreate the data table, your numbers probably won't be as accurate, okay? But you'd say, okay, here's a person with lower weight because the color here is low, and here's a person with higher weight because the color here is bright, and these are somewhere in between, but put these in order, that's kind of hard for us to do, right? But we can do that, right? And so on the surface, representing a number with a y-coordinate may seem very different from representing a number with the color of a point, but at an abstract level, they are the same. We're just taking a numeric value and taking it to representing it visually somehow, okay? By altering something there. Okay? So some aesthetics only work with categorical variables, such as the shape of a point, using triangles, circles, or squares. That's only going to work with a categorical variable. Okay? Some aesthetics work with categorical or continuous variables, such as the x position or y position. Even color could work that way. When you do something like a bar graph, the variable mapped to the x-axis is usually categorical. It'll be like category 1 is this position on x, category 2 is the next position on the x, category 3 is the next position on the x. Okay? When you create a scatter plot, generally x and y will be numeric. Okay? But those aren't required. Now, that graphic that we've been kind of creating could be done entirely with base graphics, but it's a lot more of a pain. Okay? You'd have to kind of convert your categorical variable, such as gender or something, into a vector of colors. And you could do that with something like if else, and you could take the hair color and map it to like a bunch of shapes and things like that using PCH and all of this. And so this would be kind of the code required to do this. I would have to create a factor and turn them into integers and et cetera, et cetera. And I can kind of recreate the same plot. And I don't know if you've ever tried to make a legend with base graphics. Has anyone had the misfortune of trying this? Okay. It's not that much fun, okay? All right, but it can be done, right? But ggplot makes our lives a lot easier by automatically creating the legends for us, automatically doing all of this mapping and stuff for us. Yeah.
I thought that base all would automatically convert a factor into the required colors if you pass that into some categorical property. Is that not the case?
I think it does. I think it does. So, let's see. Color, shapes. I think for certain things it does, and then other things it won't. So, so here I took the factor and I want it mapped to the shape. So I wanted 3 shapes, and I don't think base graphics will do that. I think it'll do it with colors though. Yeah. So if I take the colors, it would do that, and I think it would do it automatically. I think it defaults to black being the first color, red being the next color, green being the next color. And here I'm specifying I want red and blue or whatever. So we can do it that way. Okay, with ggplot, you just kind of aesthetically map and you say, I want this variable to be this attribute, and it does everything automatically for you. Okay, let's say we wanted to create a plot from scratch. Let me go ahead and give you your second view quiz answer. Second view quiz answer is E as in elephant. E as in elephant. All right, so the requirement for ggplot is your data has to be made tidy. Basically, each variable has to have its own column. Otherwise, ggplot's not going to work. Okay, so first, if I just do this, let's map height to x and weight to y. And you do this, you're going to just get a blank thing. And I have a feeling somebody might have done some of this at some point in your career, and you're like, why is ggplot not working? Okay. And it's because you haven't added any kind of geometric object. So you have to add some kind of geom. And so here I'm going to say, let's add a geom point. So here we said height goes to x, weight goes to y. And we're going to just say, you know what? Add points. Okay? So it goes through our data. It looks at our data. It says we've got 6 points. We're going to put, and we're going to graph those 6 points here. Okay? Now, if we want, we can also map, say, the value gender to the color. Okay? So we're going to, I could put this mapping, gender to color, in this aesthetic mapping, or I could also put it inside, an aesthetic mapping inside the point object. And it does this. It maps color to the gender. Now, this is a little bit hard to see because the points are so small. So you can change the settings of this thing, okay? Settings are different from aesthetic mappings. Settings are settings. There is no information carried, no data information carried in the setting, right? So when I say geom point size equals 10, color equals blue, we are going to set all of the values to be blue, set all of the size of the points to be 10. And it's going to look like this. But there is no information of the data being carried in either the color or the size of the point. The color blue doesn't represent anything from the data. Every single point is blue. The size 10 doesn't represent anything in the data. Every single point is the size 10. Okay? So we could, you could map, say, gender to the color and then use a setting for the size or something. You can map an attribute to the size as well. We can change the scale. Our ggplot automatically determines the scale. It just kind of looks at the minimum value and the maximum value and says, I'm going to draw my endpoints here and here. But you can say, you know what? I know better, and I know that the limits should be here and here. So we can say the limits should be 60 and 100 or something. And you can alter the scale this way as well. Okay, and so now we have space for higher values. Okay, and that's what we have. You can it automatically maps. It will automatically figure out what colors to use. All right, but if you don't like the colors, you can tell ggplot, I want to change how to color the values. All right, and so we're going to say scale color manual. So remember, scales are for how to go from the data values to visual properties. So going from data values to visual properties would be what colors to use. And so I can just say orange and forest green, and you can look up named colors in ggplot, and there's a bunch of colors that have names and stuff, and I don't know them all, but this is what we have, and this is what orange and forest green, those colors are, and we have the points represented here. Okay, now when I create a plot, right, to produce these things, I've been using kind of P has the original base mapping, which is ggplot, AES, height, and weight. And then later on to each of these things, I'm just calling P plus geom point. Okay, so I'm going to P plus geom point. And that's what I'm doing here. All right. If you want, you can get rid of some of the background things. So this projector you can't see. On the slides you can see. But in the projector, there's kind of a gray background and white axis lines. And also, in this thing, it's gotten rid of the gray background and it put on these light gray axis lines. Okay, but with the projector you can't really see it. Again, on the slides you can see, you can kind of just change the themes of how these lines are drawn. And this, so one of the themes I like is theme black and white, but there's other themes as well. Okay, one kind of thing is that in R's base graphics, the graphing function tells R to draw graphs to the output, which is output device, which is usually the screen. But you can also specify a file that's like your graphics device. Okay. Now in ggplot, the commands don't directly draw to the output device. What you have to do is you have to kind of print the object. So you call print on the object, and a lot of times you don't. It feels strange because you don't generally call print on the graphs. But that's because whenever you type something into R, its default behavior is to print whatever that thing is. It prints out, whatever gets returned. And so the behavior is different inside a function and a script. If you want the graphic to be produced, you have to explicitly call print on the graphic that you've made. Okay. There's a few other things. So like stats can be calculated. So for example, if you think about how do you make a histogram, if you had to make a histogram manually, it's kind of a bit of work because you kind of have to bin your values and you have to turn them from numeric things. You basically have to take your numeric values and turn them into some kind of categorical values where you say there's this many values within this categorical range of like 0 to 10 and 11 through 20 and 21 through 30 and things like that. And there's a bit of work involved. But it's such a common graphic that we ask for. ggplot has this built in, and you can say geom histogram, and it's automatically going to bin them and draw them for you. Okay, and things like that. All right, I'm going to run out of time, but I'll just do as much as I can here. There's kind of the basic plots I want to talk about are the basic geometries are the point geometry, which we've seen. We also have the line and the bar geometry. And basically, the other ones, histogram and box plot, are also useful, but I won't really cover those in these slides, and I'll let you look at these on your own time. Let's start with bar graphs, okay? Sometimes you'll have a chart, and here, one column represents just the group. So we got control, treatment 1, treatment 2. That's going to be on the X position. And Y, this is just the value you want plotted, okay? Here, I'm going to do geom bar stat equals identity, because that's going to specify not, because geobar normally just counts up how many times a certain value appears, but here we want to actually plot the height of the bar to be 5.032 and the height of the bar to be 4.661. And so that's going to require geobar stat, the property to be the identity. And then the group goes along the x-axis. So we have control, treatment 1, treatment 2. Here is something where I've got two categorical variables, the cultivar 39, cultivar 52, and I've got the date, day 16, day 20, day 21, and these are, we're going to treat as categorical variables. And then we've got some kind of, we're going to plot the weight, okay? So here I'm going to map the date to the x-axis. So we're going to have 3 positions on the x-axis, day 16, day 20, day 21. We're going to map y to the weight, okay? The weight's going to go to y. And we're going to map the fill color to the cultivar. So we're going to see 2 colors represented, the 2 fill colors. And as far as the bar graphs, we're going to specify stat equals identity because we want the height of the bars to be equal to the actual values that we see in weight. And then position equals dodge puts them side by side. So this is what we end up getting. We end up getting 3 positions for date, day 16, day 20, day 21. 2 colors for fill color, red and blue, and then the height of the bars are the height of this thing, okay? The other variables just didn't get mapped, so those aren't represented in our visualization. The default behavior, geobar, is to go through and just kind of summarize all of the counts. It's going to go through and just count up how many times a certain value appears. And so here's our diamonds data set, which has around 54,000 rows in it. We're going to look at, I think, the cut. So we have ideal, premium, good, very good, stuff like that. This is a factor. It's an ordered factor. And so when we create geobar, there's only one attribute mapped here. We're going to map the cut to the x-axis, and then by default, ggplot maps the counts of cut to the y-axis. So that's going to automatically kind of be counted for us and get mapped. And because cut is an ordered factor, it's going to put it in the order that it appears, the orders that the levels appear, which go from the worst grade to the highest grade possible for diamonds, which I don't know if any of you are in the market for diamonds, but apparently ideal is the best quality of cut you can get. All right. And so this is what we have. Let's, you can map all sorts of attributes to different things, okay, such as the fill. All right, so here, this is, I think this was looking at the 2000 data census and the 2010 census. So this is all outdated now. But we're looking at, you know, which states grew the most in that 10-year change. And Nevada grew like 35% in the year from 2000 to 2010. And so here, what did I do? I mapped the abbreviation of the state, okay, AZCOFL, to the x-axis, and it does this in alphabetical order by default. We're going to map the height, the change value, numeric value to the height, and we're using stat equals identity. And the fill is going to be the region. So we're just asking, you know, did the growth happen in either the region? And I guess we just said this is either in the west or the south. And so that's what we have, okay? So we've got kind of 2 colors here. Here, what did I do? Now the color, I'm mapping change to both the y and the color, okay? So now we're like kind of double emphasizing this variable. And so we can see, oh, you know what, Nevada is the brightest. That had by far the most amount of growth represented in this data set, okay? You can rearrange the values based on a variable. So here I'm saying take x, and x, we want the abbreviation, but we want it reordered based on the change variable. So by default, if you give it a categorical or something that looks like strings or characters, it's going to arrange them alphabetically. That's the default behavior. But you can say, I want it reordered based on the variable change. And so we have this. So it's still mapping abbreviation to the x-axis, but it has now reordered it based on the change. Okay, custom colors. These are supposed to be UCLA colors. So I did scale fill manual, okay, and here we said fill is going to be the region. So, how is the fill colors going? If you want something like a gradient, you can specify the colors of the gradient. So the default gradient is like dark, dark, dark blue to bright blue, and you can specify to like red to blue, and you get purple somewhere in between, things like that. That's what we have. Okay. All right, I'm out of time. You'll have to look at these slides on your own. So this covers line graphs, and things that you can map to a line graph. So you have X and Y position. You can specify, you can map colors of the line. If you're dealing with like a printout, you can map the line type, and it'll be like dashed lines and solid lines, stuff like that, okay? That's pretty much all I had to say for lines. And then for scatter plots, you've got the points, and you can kind of change what symbols we use. So rather than dots, you can have circles, okay? You can specify the size of the dots. You can specify the color of the dots. You can specify the shape of the dots. Now, the shape of the dots is pretty not helpful, okay? It's there, but it's hard to see, right? Here you can kind of clearly see a distinction between red and blue a little bit. And you can see, red and blue are quite mixed over here, but this is age versus height, split by genders. So, around age 12, both genders similar in heights. By age 16, 17, there's kind of a difference showing up, between heights and things like that. All right. And then this last section where you're plotting data from multiple data frames. Okay, so you might have one set of data and another data frame, and you want to kind of plot both of these things. It can be done, and I've got instructions or examples of how that's done. And it will be useful for homework 5, which is way in the future, but it's coming also. All right. I've posted homework 4. I think a lot of you are still kind of wrapping up homework 3, which is fine. But homework 4 has been posted. That's going to be due Valentine's Day, February 14th. So you have that to look forward to. But homework 4 is posted. Anyway, that's it. Okay. Have a good rest of your Friday, and we will see you guys. Oh, third question. Thank you for that reminder. Yes, D as in dog. D as in dog is your third view quiz answer. D as in dog. D. Okay, that's it. Have a good Friday. Have a good weekend. We'll see you guys next week.